Hello everybody, I welcome you all for the second session of this OSI Layers and its responsibilities. In the previous session, we discussed about this physical layer, data link layer, network layer. These three layers, which are called as the hardware layers. The rest of the layers are called as the software layers. Today, we discuss about in the second session about the transport, session, presentation and the application layers. First, I start with the transport layer. That is the fourth layer of the OSI model, transport layer. The responsibility of the transport layer is to exchange the entire information between the source to destination. Why I am using the word entire information in the sense? The previous layer, which is called as the network layer, is responsible of transporting a single packet from source to destination, but rather in the transport layer, it will transport the entire information. Why I am using the word entire information in the sense? Your information will be converted to n number of packets. The transport layer is responsible for this entire packets. It has to transport from the source to destination. The first and foremost important responsibility is called as the segmentation and reassembly. Segmentation and reassembly. In some cases, you are transporting to n number of you are crossing n number of routers to reach your destination. For example, I am taking as an example the source from one side from router 1, router 7, router 9. Then I will reach my destination. I assume this is the path which is the shortest path already have been selected from the third layer, which is called as the network layer. This is the shortest path will be preferred or selected by that network layer, which is source to router 1 to router 7, router 9, 7 to router 9, router 9 to destination. Also, I am assuming that I am having a packet size of 2000 bits per information. In each packet, it will contain 2000 bits. I am following the fixed size type 2000 bits. If suppose the router 1 can perform the 2000 bits in the sense, I don't have any problem that the 2000 bits will be pipeline to router number 7. Crossing the router number 1, it will come to router number 7. Suppose this router is not able to perform, this network or router will not able to perform this amount of information in the sense, here I am doing a segmentation process. Segmentation in the sense, this 2000 bits packet will be converted into two smaller packets. I am fragmenting here, that is 2000 bits of information. Because the router is not able to perform this 2000 bits, I am fragmenting the portion here. This is called as a segmentation. The another side, what I am doing is, I am converting these two 1000 packets into a original one. It is called as a 2000 bits of information. This is called as the segmentation and the reassembly. Next is flow control. Next is flow control. Already we have discussed this flow control in the layer 2 data link layer. That functionality will be the similar one. That means you have to slow down the process when your absorption rate of the receiver is lesser than the generation or production rate of the sender. The concept is same, but in the data link layer it is between node to node. But in the case of your transport layer, this is between end to end, from source to destination. So you can see that from source to router 1 in the sense, it is the responsibility of the data link layer. The flow control is the responsibility of the data link layer. But from source to destination, the flow control is responsible of the transport layer. The similar way, error control is also. Now I consolidate the things of the transport layer. The transport layer is responsible transporting of entire information from source to destination. Your information will be maybe converted into n number of packets. The transport layer is the unique responsible person of transferring all the information from source to destination. But anyway, in case of any intermediate network, You cannot able to process your packet size in the sense you can fragment the packets into smaller portions. The another side you can reassemble the packets. That is possible in the layer, transport layer. Then flow control, error control, functionalities are similar to the data link layer, but the end-to-end level, that is transport layer. I will move on to the session layer. Now next I will move on to the session layer. Session layer is responsible for the synchronization and checkpoints, adding checkpoints. Session layer. What we call this is a session. Session is one full duplex communication. That means any source or sender with the receiver with the full duplex mode is on, then the synchronization will be maintained by the session layer. The synchronization will be maintained by the session layer. Apart from that, what it is doing in the sense, adding some checkpoints. For example, we are transferring a 5000 bytes of information in a 1000 bytes. Each portions will be containing a 1000 bytes of information. 1000. It's equal amount of information. Okay, we are adding some checkpoints. So I started from here 1 to 1000, 1001 to 2000, 2001 to 3000, 3001 to 4000, 4001 to 5000. Suppose I am adding a checkpoint in 3001. I am adding a checkpoint in the 3001 in the sense. What is the meaning of this? That is, I am checking whether any error present in the 2001 to 3000 bytes of portion. 2001 to 3001. That is the responsibility of the session layer. Now we move on to the next layer, which is called as the presentation layer. Quickly move on to the presentation layer. The specific responsibilities of the presentation layer are the first one is translation. Second one is compression and decompression. Then third one is encryption and decryption. The specific responsibilities of the presentation layers are translation, compression and decompression, encryption and decryption. First we will see the translation. You know what is the meaning of translation? The speaker is in French, the listener is in Tamil. Then you need to put a translator which is used to convert this French to Tamil and vice versa, Tamil to French. But in nowadays we are not doing the translation process because we are using the standard code which is called as the ASCII. The information which is transferred from any computer to another computer will be the standard format which is called as the ASCII. You know what is ASCII? American Standard Code for Information Interchange, ASCII. In earliest stages, before this, the standards will be evaluated. Then that time, if one computer is using some EPCDIC code, in some computer will be using some other code. In the sense, we need to put a translator to convert this type to the next other type, vice versa. But nowadays we are following the ASCII codes. So there is no need of the translations. If you want, we can use it. The second one is the compression and decompression. You know the purpose why we are doing compression in the one side and decompression in the another side. The primary motto to compress the things, which is the reduce the storage space. to reduce the storage. This is the predominant factor why we are using a compression, why we are compressing the information. When you are compressing, you can classify as two types. One is lossless compression. Another one is lossy compression. You have two different categories in the compression. The one is lossless compression, another one is lossy compression. In lossless compression, how I am defining this lossless compression in the sense, one side I am doing a compression, another side I am doing a decompression. The decompressed information will be exactly similar that what I am doing, what I am using in the compression side, without any loss. The decompressed information, which is the original, which is equal to the original information, is called as the lossless compression. That means there is no loss happens in this compression. The second category is called as the lossy compressions. In this, you can exploit some information which will not be without this information you can meet up the perceptual quality. In the sense, you can use the lossy compressions. These two are the two different compression and decompression. When you are doing compression, you can reduce the storage space. Also, you can increase the speed of data transfer speed. For example, I am having a 15 kilobits of information. I am having a 15 kilobits of information. My link capacity is, sorry, you will take an example of 20 kilobits of information. My link capacity is 10 kilobits per second. So what is the meaning of this? Per second you can transfer 10 kilobits of information. Per second you can transfer 10 kilobits of information. Suppose if you are not compressing in the sense, it will take 2 seconds of time, because per second I can transfer 10 kbps, the next second I can transfer the remaining 10 kilobits of information, so it will take 2 seconds of time. Suppose I am reducing this using some compression techniques to 10 kilobits of information. So 10 kilobits of information in the sense, the transfer speed will be increases because I can transfer in a single way, that 10 kilobits per second through channel, I can transfer in the same time to the destination. So automatically it reduces the transfer speed also. It reduces the increases the speed of the transfer. So automatically the transfer speed is increases in the sense the network performance will also increases. Now consolidating. The third one is encryption and decryption. People, you all aware of that the cryptographic techniques. Why we are doing that encryption and decryption for the information in the sense, when we need to protect our information, the privacy is required. That time I am entering into this technique is called as the encryption and decryption. You can see it in the nowadays the WhatsApp. If you are opening the WhatsApp, you can see, you can see that the end-to-end chat is encrypted. So that means the privacy is to be maintained between the parties. I will call this as the parties are called as the authorized parties. Who is the source and who is the destination of this information are called as the authorized parties. How defining this privacy in the sense, the information can be readable between the authorized parties alone. The information can be viewed or read or to understand by the authorized parties alone. The unauthorized parties couldn't read this information, couldn't capture this information. That is possible through encryption and decryption. Hope you all know the word cryptography. A book is available. Cryptography and network security. The word crypt is the Greek language. The word crypt is the Greek language. The meaning of this crypt is secrecy. The meaning of the crypt is secrecy. So, to maintain this secrecy, we are following some properties. So, we are following some attributes of properties. The encryption and decryption, one side I am doing a encryption, that means I am jumping the information which will know only by my opponent party, rest of the persons could not be understand this concept. For doing this, I need an algorithm, encryption algorithm. Apart from that, I need one key. My information is called as plain text. In the cryptography language. Using this algorithm and using this key, the algorithm will differ. There is various classical algorithms and also extended complicated encryption algorithms are also available. Using this algorithm and key, my plain text will be converted into encrypted text. The another name for the encrypted text is called as the ciphertext. Now the ciphertext is passing through any or public or private channels. In the receiver side, they will receive the ciphertext. My authorized receiver will receive the ciphertext. They will also follow the same algorithm and key. And then they will decrypt this information. They will get the plain text. That is my original information. They will get my original text. It's called as the plain text. In some notation manner, I can write this for your understanding purpose. In the transmitter side, I am using the plain text. The plain text will be encrypted using one algorithm, encryption algorithm E, by using one key K. This P denotes the plain text. By using some encryption algorithm, it is being encrypted with the help of key K, which is equivalent to my encrypted text, which is called a ciphertext. Then you would see that in the receiver, they will receive the ciphertext C. Okay. Then they will decrypt this information D with the same key K. They will get the plain text P. Okay. This is the process of your encrypting the information in one side and decrypting the information in the another side to provide the secrecy, to maintain the secrecy between the pair of parties. The others haven't the knowledge of this algorithm and the key, so they haven't decrypt your information, but the hackers will work more predominantly to know what is the information, what is the ciphertext which is passing between you and between your partner, and they will try to hack this information. And moreover, I could see some difference in this techniques. In the for the encryption and decryption, if you are using the same key, in the sense it's called as a symmetric encryption scheme. The same key will be followed by encryption. The same key will be used to decrypt this information is called as the symmetric encryption types. If suppose you are using two different keys, that means you are using the public key to encrypt, public key of your opponent to encrypt this information in the encryption side, and they will use their own private key to decrypt this information is called as the asymmetric encryption algorithm. Again I will repeat. Suppose if you are using the two similar keys, the same key will be followed in the encryption side, the same key will be used in the receiver side to decrypt this information is called as the symmetric key encryption algorithms. Suppose if you are using two different keys in the sense, always I am using my opponent public key to encrypt this information. My opponent will use their own private key to decrypt this information. To understand this scenario, then I will write some example. For example, you have three parties are there. That means X, Y and Z. To understand this concept of the public and private key encryption schemes. X having its own private key and public key. Y its own public key and private key. Z its own private key and public key. But in this communication, what they will do in the sense, they will share the public key to the opponent. X public key is available with Z and Y. Y public key is available with X and Z. Z public key is available with Y and X. But their own private keys are with them alone. Its meaning, it's a private. So the private key is only available with them alone. So if X and Z wants to communicate, what they will do in the sense, the information, the plain text will be encrypted using the public key of Z. PUZ. Public key of Z. Now this information is passing to the Z. Suppose the same information will reach Y also. We will see in the later case. Now I am encrypting this using the public key of the Z and I will pass this information to the Z. Now what Z will do in a sense, Z is using their own private key to decrypt this information. Z will use the private key to decrypt this information. This is called as the public and private key cryptography, or else it is called as the asymmetric encryption schemes. You could see the same information which I want to transfer to Z may goes to Y also, but the Y cannot decrypt this information. Reason is the information can be decrypted by the private key alone. Then you may ask the question, sir, Y is also having its own private key, but I am using the public key of Z to encrypt this information. So this combo, this information will be decrypted by the respective person's private key alone. So the Y could not be decrypted this information. In such a way, you have various versions of the algorithms like block cipher, stream cipher, encryption schemes, and number of recent complicated algorithms are there to encrypt and protect your information security. The level of encryption algorithm, what we are considering is how to it is complicated, that much security we can offer to the network. So this is called as the presentation layers responsibilities. Now you consolidate this information. The first one is translation. That means one form of code to the another form. And I told you, all of we are using the ASCII codes. There is no need of translation. If suppose it is applicable, one computer is using ABCDIC code, some other computer is using some other codes. In the sense, you have put a translator to translate these informations. The second one is compression and decompression. The meaning that reduce the storage space and increase the speed. We go with the compression and decompression. Even though you have two different types, compression, lossy compression, lossless compression. In all the cases, we will not go for the lossless compression. In some portions like images, sound, the pictures, according to the perceptual quality of the ear and eyes, then we can wire some portions without affecting the information. We can go with the lossy compression schemes that we discuss in the next session, how we can use for which type of media you can use the lossy compressions, for which type of media you should use lossless compressions in this sense. Third one is the most important. Even though you are doing anything, the information security is most important. For this we are using the encryption and decryption. That is the very specific responsibility of the presentation layer. And then I explained that what is the symmetric key encryption, what is asymmetric key encryption. The RSA algorithm is the best example for the private key, public key cryptography techniques. So next I move on to the last layer is called as the application layer. So we discussed all these 7 layers in these 2 sessions. The last and foremost and uppermost layer is called as the application layer. So far I discussed so many protocols, so many things. If these are all applicable only when this protocol stack should be good. Hello. For example, if you are transferring a mail from one computer to another computer, you need a SMTP protocol in your application layer. Simple mail transfer protocol. Simple mail transfer protocol. If this protocol is applicable in your application layer stack, then only you can go with the mail transfer application. For example, if you want to transfer your file between one computer to another computer, then you need a protocol. In your protocol stack, you need a FTP. That is called as the file transfer protocol. File transfer protocol. You want to maintain the management of your entire network. You need SNMP, Simple Network Management Protocol. Simple Network Management Protocol. If these kind of protocols are available with your protocol stack, then you can freely run. Then what I am saying, that whatever the applications you can access, you can use, and you can do it. This entire protocols will be available in the protocol stack. It's called as the application layer. For understanding these concepts, some of the very good reference and textbooks are available. Then you can follow that data communication by Ferozan, Begarus, Ferozan, and Tannenbaum. These books giving closely very good insights and the pictorial representations of each layers. When in the case of the Begarus Ferozan book, you are following that the layers will be explained with the clear depictions of the pictures. Then all these informations I learned through this book. It's very simple in English. People can read it, then you can understand it. So for my recommendation is, you can follow the data communication by Begarus Ferozan book for this topics, and then almost you have different lectures available. If you have any doubt, then you can post the queries in this channel, then I will explain the concepts. In the next session, I will discuss about this media layer, that means data link layer. What are the other specific responsibilities of the data link layer, and what is the IEEE 802 series in the next session. Yeah. All it is coming under the 7 layer only. The entire communication networks, the subject will be framed is followed by the 7 layers only. So if you know the concepts and understanding the basics of the communication networks by using this OSI layer model, then you can study anything about the advanced wired and wireless communications, 5G, 6G communication technologies, advanced wireless communications, even wired in a sense fiber optic communications. You can learn the advanced levels by using the knowledge of the basics of the OSI model. If you thorough in OSI model, then you can understand what I am saying, that the wireless categories of 5G, 6G. You can understand the concept of the optical communication, radio over fiber schemes, advanced wireless communications. Everything is coming under this framework. Each layer has its own responsibility. So all these networks will cover, wired wireless will be covered with the help of OSI model. Hope so you can understand all these concepts. Thank you for your patience and understanding this. Thank you.